Welcome back. In this lesson, lesson 4 of Module 1, we're going to identify proportional and non-proportional relationships in tables again, but we're going to be comparing two things. In this example, we're looking at two teams that are walking in a long distance race. We've got Team A and Team B. Team A walks at a constant rate of 2.5 miles per hour. That means every hour they go 2.5 miles. So this is the table for Team A. After 1 hour, Team A will go 2.5 miles. After 2 hours, they will have gone a total of 5 miles. 2 times 2.5. After 3 hours, they will have gone 7.5 miles. After 4 hours, they will have gone 10 miles. After 5 hours, 12.5 miles. And after 6 hours, they'll have gone 15 miles. Team B is slightly different. They walk 4 miles in the first hour. So for the first hour, they go 4 miles. And then 2 miles per hour after that. 4 miles in the first hour, and then 2 miles every hour after that. So in the second hour, we're going to add 2 to 4, and we will get 6. In the third hour, we'll add 2 to 6 and get 8. And fourth hour is 10, fifth hour is 12, and the sixth hour is 14. We ended up adding 2 each time until we were all the way done. For Team A, we added 2.5. If we added a row above this, if we took a look at 0, to go from 0 miles to 4 miles, we added 4 miles. We start 0 here and 0 miles. To go from 0 miles to 2.5 miles, we went 2.5 miles. If you look at how things were added over here, we were adding the same thing even from 0 every time. For Team B, we added something different at least one of the times that we moved up in our table. So if we look at this, for which team is distance proportional for time, we can see that Team A is proportional. The value of the ratio for each of these would be the same. We would have 2.5 divided by 1, 5 divided by 2, 7.5 divided by 3, 10 divided by 4, 12.5 divided by 5, and 15 divided by 6. For each of these values, the answer is 2.5. That's the value of each of these ratios. If we look over here, we find the first ratio, 4 divided by 1, the value of that ratio is 4. But the value of 6 divided by 2 is 3. 8 divided by 3 is 2 and 2/3, or 2 and 0.6 repeating. 10 divided by 4 is 2.5, or 2.5. So that's the only one that matches over there. And 14 divided by 6 is 2 1/3, or 2.3 repeating. As you can see, the value of each of these ratios is different. So if only Team A is distance proportional to time, I can say that Team A has a proportional relationship. The value of each ratio in the table is the same. For part B, if I want to explain how I know the distance for the other team is not proportional to time, I can say Team B does not have a proportional relationship because the value of each ratio is different. Question C asks us, at what distance in the race would it be better to be on Team B or Team A? If we look in the race, here's our distance. If it's better, then you probably want to be ahead. So we're looking to see where would it be better to be on Team B than Team A. And it looks like all the way up at the first hour, Team B is ahead. At the second hour, Team B is ahead. At the third hour, Team B is still ahead. But at the fourth hour, they're tied. They have the same distance. So if we wanted to explain that, we could say it is better to be on Team B during the first 4 hours of the race. During that time, they are ahead of Team A. Question D asks, if the members on each team walked for 10 hours, how far would each member walk on each team? If we look at these, we would continue it out for 10 hours. For Team A, we know that we can just multiply it by 2.5. So for Team A, we would do 10 hours times 2.5 miles per hour. That would be a total of 25 miles. Team B is a little more difficult to figure out. In Team B, for 9 of the hours, they walked 2 miles per hour. So that would be 18 miles. But for 1 hour, they walked 4 miles per hour, that first hour. So that would be 4 hours, or 4 miles. The two together equal 22 miles in total. So that means Team A would walk 25 miles and Team B would walk 22 miles. Even though they were faster at the beginning, 4 miles in 1 hour, they were slower every other mile. They were only going 2 miles per hour, where Team A was going 2.5 miles per hour. Question E asks, will there always be a winning team, no matter what length of the course? Why or why not? In order for there to be a winning team, one team has to be ahead of the other. If we look and see, at 4 hours, both teams have walked the same number of miles, so they would tie. So the answer is no. When Team A and Team B have walked the same number of miles at hour 4, there would not be a winner. Question F asked, if the race is 12 miles long, who should you choose to win? If we look at the distance and find 12 miles, Team A gets to 12 miles somewhere before hour 5, a little earlier than hour 5, because at 5 hours they've gone 12.5 miles. Team B, if we look at our table, takes 5 hours to go 12 miles. So Team A gets to 12 miles first. We can also look as a proportion. We can say if they can go 1 mile or 2.5 miles in 1 hour, how long would it take them to go 12 miles? Well, 1 times 12 divided by 2.5, this is going to be 4.8 hours. So it'll take them 4 8/10 of an hour, a little more than 4 hours and 45 minutes, to go 12 miles. But it takes Team B 5 hours to go 12 miles. If we put it this way, Team A will reach 12 miles before 5 hours at 4 8/10 of an hour, and Team B will take 5 hours to go 12 miles. So I would choose Team A. The last question says, how much sooner would you finish on that team compared to the other team? So how much time would you take if the race was 12 hours long? And we figured that up here. If we needed to go 12 miles and we went 2.5 miles per hour and we wanted to go 12 miles it would take us X hours. We would write 12 times 1 divided by 2.5. That would give us 4.8 hours. If we want to know how much sooner, Team B is 5 hours. So 5 minus 4 8/10, that's 2/10 hours sooner. So this was the time it takes Team A. 5 hours was the time it takes Team B. And the difference between the two of them is 2/10 of an hour, which is a little less than 15 minutes. All right, this was a long one, but make sure you've got all the information down. We're going to be going over it in class and then working on the exercises and problem set. Make sure you've filled out all your notes, watch again if you need to, and we'll see you in class.